At its core, artificial intelligence doesn't actually think in the way humans do. Instead, it operates on the language of probability. Every time an AI identifies a face in a photo or predicts the next word in a sentence, it is calculating the likelihood of that outcome based on patterns it has seen before. We often visualize these patterns through distributions. A normal distribution, or the bell curve, shows us that most data points cluster around a central value, with fewer extremes at the edges. However, real-world data is often skewed, meaning the tail of the curve stretches further in one direction than the other. For an AI model, understanding the shape of this distribution is the first step in making an accurate prediction, as it defines what normal looks like for a specific dataset. Without these statistical foundations, a machine would have no way to quantify uncertainty or handle the messy randomness of the real world. To summarize a massive dataset into something a model can use, we look at measures of central tendency, the mean, median, and mode. The mean is the arithmetic average, but it can be easily pulled away by outliers, extreme values that don't represent the group. This is why we also look at the median, which is the exact middle point of the data, and the mode, which is the value that appears most frequently. Imagine training an AI to predict housing prices. If one mansion costs $50 million while every other house costs $200,000, the mean would be misleadingly high. The AI needs to weigh these different centers to understand if it is looking at a typical case or an anomaly. By identifying these central points, the model creates a baseline from which it can begin to measure deviations and recognize complex patterns. Once an AI understands individual variables, it begins to look for relationships between them using correlation and linear regression. Correlation tells us how much two variables move together, but we must remember the golden rule of statistics. Correlation does not equal causation. Just because two things happen at the same time doesn't mean one caused the other. To turn these relationships into predictions, we use linear regression. Visually, this is like drawing a line of best fit through a cloud of data points. The goal is to minimize the distance between that line and every single point in the set, a process often called minimizing the sum of squared errors. This line becomes a mathematical formula that allows the AI to take a new, unseen input and calculate a predicted output with a high degree of mathematical confidence. Ultimately, statistics is the engine that powers every machine learning model. When we train a model, we are actually using statistical optimization to fine-tune thousands or even billions of internal weights. These weights are adjusted until the model's internal probability distributions align as closely as possible with the real-world data it's studying. Whether it's a simple regression or a massive neural network, the goal is always the same: to reduce loss, which is just a statistical way of saying the difference between the truth and the guess. By mastering these statistical concepts, we move beyond seeing AI as a black box and begin to see it for what it truly is: a sophisticated system for calculating the most likely version of reality.